Welcome back to RamZland. Today I want to share with you the amazing acid-base reaction between elemental sodium and acetylene gas. Check this out. For this reaction, we'll use elemental sodium stored in mineral oil because it reacts with water. A 4,000 milliliter Erlenmeyer flask. This is a deflagration spoon. We're using calcium carbide to generate acetylene gas, my blowtorch, and about 50 milliliters of distilled water. Sodium is an alkali metal. It has a melting point of 208 degrees Fahrenheit with 11 protons. Sodium was discovered by Sir Humphrey Davy in 1807 through the electrolysis of molten sodium hydroxide. Because acetylene gas is highly flammable, this must be done behind a double blast shield over a flame blanket. The first step is to take a couple pieces of calcium carbide and drop them into the bottom of a 4,000 milliliter Erlenmeyer flask. Next, add just a little bit of water, and immediately you'll see the production of acetylene gas. Cover the flask with a watch glass to keep the acetylene gas inside the flask. The next step is to take a piece of sodium out of your mineral oil and cut just a small piece that you can fit on the end of your deflagration spoon. You'll notice that sodium has this dull gray oxidation layer, but when you cut it, it's bright and shiny, has kind of a silver luster to it. It turns gray pretty quickly as it's exposed to oxygen in the air. But you want to get a small piece that you can fit on the end of your deflagration spoon, and you can kind of squeeze it almost like silly putty. That's about right. So one of the products in this reaction is sodium acetylide, which is the salt of acetylene gas, which historically was used to make some detonators. So expect a really loud kaboom in this reaction. Now you're ready to start heating up your piece of sodium on your deflagration spoon. You want to do this until it's molten. But you don't want it to be on fire, you just want it to be heated up, so it's molten now. Now very carefully I'm going to remove the watch glass over my acetylene gas, and I'm going to lower my sodium into the flask. Alright, here we go. And here are our products. Sodium acetylide, you can see a little bit of white crystal on the edge of the Erlenmeyer flask, and of course hydrogen gas. Here's the balanced equation for this amazing acid-base single displacement reaction. We start with the reactant sodium and acetylene gas. We have 2 moles of sodium, that's the 2Na, and 1 mole of acetylene gas, that's the C2H2. When those combine and activation energy is added, we get the products sodium acetylide and hydrogen gas. We have 2 moles of sodium acetylide, that's the 2NaC2H, and we have 1 mole of the diatomic molecule of hydrogen gas. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.